Computer networks are everywhere these days. They connect our computers, phones, and even our refrigerators. But what exactly is a computer network? Simply put, it's a way to connect two or more computing devices together so they can share information and resources. This connection can be through wires, like Ethernet cables, or wirelessly, like Wi-Fi. Think of it like a group of people who want to share their ideas. They can talk to each other directly, which is like a wired connection. Or they can use a whiteboard to share their thoughts, which is like a wireless connection. Computer networks allow us to do so much. We can share files, print documents, and access the internet, all thanks to networks. In the next section, we'll explore different types of computer networks and their unique characteristics. Just like there are different ways to connect people, there are different types of computer networks. Each type is designed for a specific purpose and has its own strengths and weaknesses. Let's look at some of the most common ones. 1. LAN, Local Area Network. Imagine a small office with several computers. They want to share files and a printer. A LAN is perfect for this. It connects devices within a small area, like a home, office, or school. LANs are usually fast and secure. 2. WAN, Wide Area Network. Now imagine that same office wants to connect with their other branches around the world. This is where a WAN comes in. It covers a large geographical area and connects multiple LANs together. The internet itself is a giant 1-3-MAN, Metropolitan Area Network. A MAN is like a bigger LAN, connecting different locations within a city or town. For example, a university with multiple campuses might use a MAN. These are just a few examples of the many types of computer networks. Each plays a crucial role in our interconnected world. In the next section, we will delve into the world of IP addresses and learn about the devices that help networks function smoothly. Every computer on a network needs a unique address so that it can be identified. This address is called an IP address. It's like a phone number for your computer. When you send an email or visit a website, your computer uses IP addresses to find the right destination. There are two main types of IP addresses, IPv4 and IPv6. IPv4 is the older version and uses a 32-bit address, like 192.168.1.1. However, with more and more devices connecting to the internet, we're running out of IPv4 addresses. That's where IPv6 comes in. It uses a 128-bit address, providing a virtually inexhaustible supply of addresses. But how do these IP addresses actually work? That's where network devices come in. These devices act like traffic controllers, ensuring that data flows smoothly between different parts of the network. Some key network devices include 1. Routers. Think of routers as the post office of the network. They direct data packets between different networks like your home network and the internet. 2. Switches. Switches are like traffic lights within a network. They connect devices within a LAN and ensure that data reaches the correct destination. 3. Access points. These devices allow wireless devices like laptops and smartphones to connect to a wired network. Your Wi-Fi router at home is an example of an access point. In the next section, we will explore the languages that computers use to communicate on these networks. Network protocols. Section 4. Network protocols and the OSI model. Just like humans use languages to communicate, computers use network protocols to understand each other. These protocols are sets of rules that govern how data is transmitted and received over a network. One of the most important protocols is TCP/IP, which stands for Transmission Control Protocol, Internet Protocol. It's the foundation of the internet and ensures that data is delivered reliably between different networks. TCP is like a careful courier, dividing data into packets, numbering them, and ensuring they all arrive in order. IP, on the other hand, is like the addressing system, ensuring that each packet knows where to go. Another crucial protocol is HTTP, or Hypertext Transfer Protocol. This is what your web browser uses to communicate with websites and display web pages. When you type in a website address, your browser uses HTTP to request that page from the web server. To understand how all these protocols work together, we can use a model called the OSI model. OSI stands for Open Systems Interconnection. This model divides network communication into 7 layers, each with its specific function. Think of it like baking a cake. Each layer of the OSI model is like a different ingredient or step in the recipe. You need all the layers to work together to get the final product, a delicious cake, or in this case, seamless network communication. In the next section, we will discuss network security and some basic troubleshooting tips for common network issues.